Okay, so here are your chapter 4.2 notes, and it's about solving systems by elimination. Just to refresh your memory, 4.1 is about solving systems graphically, and so we looked at the graphs of the two systems and found out where they intersected at. Today we're going to do it algebraically, and if you remember in algebra, elimination means we're getting rid of a variable, and the only way to get rid of a variable is to cancel stuff out. So keep that in mind for every single problem that we do. The goal is to cancel out a variable. So in example 1, if my system of equations looks like this, okay? When you're doing system by eliminations, you're thinking about adding down. So you're adding the two equations together. Well, in this case, I have a positive y and a negative y. What's going to happen when I add them together? Voila, it will eliminate. So in this case, the problem was pretty much set up for me. I didn't have to do anything except recognize that these are going to cancel out. So if I have x plus x, that gives me 2x. Y minus y cancels out. Remember, always bring your equal sign down exactly where it started. And 3 plus 1 is 4. Now, is this an equation I can solve for? Sure. I can divide the 2. That gives me x equals 2. Now, remember, a system of equations has two answers. Okay? So once I have one of them, I'm going to come back up here, pull one of my equations. It actually doesn't matter which equation I'm going to pull, and plug this in for the x, okay? So 2 plus y equals 3. I replaced the x with 2. Now I can solve for y. Okay, so that's how elimination works. We're going to add down. Okay, to eliminate. Okay, and then plug back in to get the other answer. Now, this step will not always be as easy as just adding straight down. Sometimes we're going to have to change the way the equations look a little bit in order for this to work. Okay, so in example 2, here are my system of equations, and as you can see, if I add down there, I don't get elimination, and if I add down here, I don't get elimination. So we have to do something. You have to have a little bit of a creative mind to do these problems because there's no book that's going to tell you what to do for every single problem that you see. You have to decide that. So I'm going to try to eliminate the y. In order for these to eliminate, I need the same number in front, and one of them needs to be positive and one of them needs to be negative. So the easiest way to create that is to take this equation and multiply by 2. Okay, so when I do that, I get 6x minus 2y equals 8. Notice all three things got multiplied. I'm not going to touch the bottom equation. But now, when I add down, is that going to eliminate? Sure. 6x plus 2x is 8x. That eliminates. 24 plus 8 is 32. Divide by 8. X equals 4. Remember, I'm not done. I have to find an x and a y. Okay. Doesn't matter which equation you plug into. I usually try to do the one with less numbers, but it doesn't really matter. Remember, I'm plugging in. That used to be the x. okay, but I replaced it with a 4. Okay, couple of different ways. I know everybody solves this problem a little bit differently. Some people subtract the 12 over and then multiply by -1. I like to add the y over just to make it positive. I can't combine these though. I haven't really done anything to simplify. I just moved the y over so that it's positive. And then subtract the 4. Okay, so still the same 2 steps, it's just this one was a little bit harder. I still had to use addition to eliminate, but I had to modify the top equation first. Once I got that to eliminate, I took this number, plugged it back in to get my other answer. Okay, so that's if you have to multiply one of the equations. Okay, keep in mind you are allowed to multiply by a negative number. So if you need one of the variables to be negative in order to cancel out, that's absolutely okay. They do try to make your life pretty hard on some of the problems by giving you fractions, but let me show you a nice easy trick to help alleviate that problem. Okay. Trying to make sure. Actually, let me do one without fractions first, and I'll end with the fractions. So. Okay, in this example, I'm going to show you how it is possible to multiply both equations by a number before you do the elimination method. Now, that's actually not necessary in this one, but I'm going to do it with the x's instead of the y's. One possibility with this one is if you look at the y's, I could multiply this by -3. So I'd multiply the whole equation by -3 to get that to cancel out. So that's a possibility. But I'm actually going to work on eliminating the x's, just so I can show you an example of when we're multiplying on top and on bottom. So if I want to eliminate the x's, in this case, the y's would be easier. I just want to say that several times. If I was actually working this problem for a test or something, I would want to work on the y's instead because it's a multiple of that one. But just for demonstration purposes, okay, I need these to match. There's nothing I can multiply 2 by to get to 5, and there's nothing I can multiply 5 by to get to 2 other than fractions. Don't want to mess with fractions. So we're actually going to multiply it by each other. I'm going to multiply this whole equation by 5, and I'm going to multiply this whole equation by -2. Why do you think I had to do a -2 here? Didn't we say these had to be opposites? One has to be positive, one has to be negative. Could I have done a -5 and a +2? Absolutely, that would have worked as well. Okay, so when I multiply, I'm going to go down instead of over this time. I get 10x plus 45y equals 10. And -10x minus 6y plus 16. Okay, all I did was multiply in. Now, what happens to my x's? They cancel. 45 minus 6, I believe, is 39. 10, and y, oh, almost lost my y. 10 plus 16 is 26. Divide by 39. I am pretty sure that reduces. It does. 2 2/3. And then again, pick one to plug into. I'm going to pick this one because what's going to happen is this 3 is going to cancel out with that 3. So 5x plus 3 2 divided by 3. Remember, this was the y, and I plugged into the y, equals -8. Again, it does not matter which equation you plug into. You could have plugged into any of these 4. So 5x, see what happens is these 3's cancel out. Plus 2 equals -8, subtract 2, 5x equals -10, divide by 5, x is equal to -1/2. So here's one that had integer coefficients, but the answers ended up as fractions. My last example is going to have fractions as the coefficients. Okay, that is a whole lot of fractions. And I don't know why I switched from vertical fractions to diagonal ones all of a sudden. Sorry to my neat and organized students. All right, so I've got a lot of fractions. I have a 3 on the bottom, I have a 4 on the bottom, I have a 6 on the bottom, 2, 3, 3. And fractions are messy. When you add them, you have to get common denominators. When you divide them, you have to flip and multiply. So many crazy rules that y'all really normally have a very hard time remembering. So here's one trick. And I had actually forgotten about this trick until I saw somebody do it on their homework. And I was like, I completely forgot about that. I should teach it. Anytime you have fractions, you can get rid of the fractions, as long as it's an equation, by multiplying by the greatest common factor, or least common multiple, okay? So, the smallest number that the 3, the 4, the 2, and the 6 all divide into, okay? Least common multiple is gonna be 24, okay? All of those can divide evenly into 24. So if I multiply everything here and everything here by 24, I will get, actually, I don't even think I need, yeah, this one's 24 because it's 3, 4, and 6. Now I could probably get away with 12. Could probably do 12 here. I don't guess I have to do all of them. 3, 4, and 6, the greatest, I'm sorry. Bloop. I think I'm just gonna stop that one.